Hello, Sam from Tool Hut. I am a mobile programmer, mobile diagnostics guy in Michigan. We also do a lot of remote programming, remote assistance for customers, and we also carry all the equipment that you need to do programming and diagnostics. Today's project is a 2014 Ford Transit Connect van. Now this is a little different than what I've done in the past. This is a case study. It's at a transmission shop. The transmission has been replaced with a remanufactured unit. There were several codes in it. The codes that were present before the transmission was pulled are the same as the codes that were done afterward. It's my understanding that the transmission case was broken and transmission fluid was coming out of it everywhere. So the complaints are, it has a severe harsh engagement. If you put it into reverse, it just slams into reverse. There's 4 codes that were there before the transmission was removed, and they're back after the transmission was replaced. So I was called in to do the mobile diagnostics work. We're going to concentrate on a couple of things, go through my strategy, my thinking of how I got to where I am. The codes I have are a P0715 input turbine speed circuit problem, a P0717 input turbine speed no signal, a P0765 SSD or shift solenoid D circuit, and a P0768 shift solenoid D electrical. I have never worked on a 2014 Ford Transit Connect transmission before. So, it comes down to how do we start this diagnosis? What do we focus on first? The extremely harsh engagement, my thought process is that if we can clear up these codes, maybe the harsh engagement will go away. So I've decided to kind of just put that to the end. The multiple transmission codes, I've just made a decision with no real expectation. I wanted to address the input turbine speed signal first. This is the input signal from the transmission to the powertrain control module, and it may or may not affect my shift solenoid D problem. So like I say, it's kind of what I decided to focus on was the P0715, P0717 codes first. I do not like unplugging, removing, inspecting a lot of stuff before I gather some data. I don't mind doing a visual inspection. In visual inspection, like I say, I'm not familiar with this van. I've decided to let's just grab the scope and get a turbine speed signal. It is, here's my schematic. It's pin 16 at the powertrain control module. So I lifted it up, put it on a hoist, pulled the left front wheel off, and I have pierced the wire at the PCM. I know you guys are going to scream at me for piercing the wires, but like I say, I don't want to unplug anything. I don't want to try to affect the connection that I'm at, because these are codes that were there before the transmission was replaced, and they're still there now. So, if it's a connection problem, I don't want to fix the connection problem. I kind of doubt it's a connection problem at this point because they were there first. So I just pull up my schematic, and I grab my scope, and here is the schematic and the pattern that I get from my input turbine speed sensor circuit, from my turbine speed sensor. So even though I'm not familiar with this 2014 Ford Transit Connect van, I'm pretty confident that this is not a good signal. I'm expecting it to pull the signal to ground. I'm expecting a 5-volt square wave. That's what I'm expecting to see. This pattern to me doesn't make any sense. It's not getting a connection, not getting a ground from what I can tell. I did put a meter on the pins at the PCM for power and ground. I apologize, I don't have a scope pattern of it or a picture of the meter, but I had a 5-volt power and a ground at the PCM, and I've decided at this point that it's time to get a better connection at the turbine speed sensor itself. So what I have done is I have reached up and unplugged the turbine speed sensor. It's on top of the transmission near the left side of the transmission. And once I unplug it, now I give this connection a visual inspection. Here's a picture of the connector. It's obvious that this is a problem. I don't know if it's the problem, but it is a problem. So I fix this connection, and then I rescope my pattern, and here's my pattern afterwards. So it's apparent that I have fixed my turbine speed sensor problem. Now it's time to clear the codes and see what returns. The good news is my turbine speed sensor circuit codes do not return. I have started the transit connect van. Now my shift solenoid D codes are back. So I decide, since, like I keep saying, I'm not real familiar with this van, my thought process is that shift solenoid A should react exactly the same way shift solenoid D does. Maybe not exactly, but I should get an idea what this is going to look like if I activate it with this scanner. So I've got my IDS hooked up, and I activate shift solenoid A, and this is the pattern I get at the PCM for shift solenoid A. This is what we're going to call our known good, because I'm not getting a code for this circuit. So I go back and I pierce the wire at the PCM for my shift solenoid D, and I activate it with the IDS. It doesn't do anything, but the code won't clear. So my thought process is that the IDS is preventing it from doing something, or it doesn't like the circuit, so it's not going to do anything. So, the question becomes, where do we go from here? We know it's a circuit problem. It's a 5-volt reference circuit. How do I test it? What do I do? So, because of the connection at the turbine speed sensor, I decide that I'm going to unplug the transmission solenoid pack on the front here of the transmission, and I'm going to make sure that I don't have the same problem going on here, because it looks to me like somebody did some electrical tests prior to me getting here, prior to the transmission being replaced probably. I don't see any indication that they've done anything at the solenoid pack. So I decide that I'm going to test the wire. I'm not a big fan of power probes, but I do like to use my power probe to do a test like I'm about to do here. So I disconnect the engine control module, the connector, and I use one of my AES wave connectors on the end of my power probe, and I hook up a test light at the other end of the wire, and I activate it with my power probe. To me, this is going to tell me if my wire has integrity. If it can light a test light through a power probe, then I really believe that I've got integrity in my circuit. The test light does not light. So now I know that my problem is between the PCM and the solenoid pack connector. I do find a corroded wire inside this connector after I've cut it open. Again, I did not get a picture of it. I guess you'll have to trust me. I fixed the wire. Actually, there was 2 or 3 wires in here that were corroded, so I fixed all 3 of them. Got it all wrapped back up, and my shift solenoid D code goes away. And I still have my harsh engagement. I don't have any indication of where to go with my pressure, for my pressure control. It is topped out. It is 100% pressure control commanded. I can't get it to uncommand it, and the decision is made that we're going to put a PCM in it. I hate doing this. It just drives me crazy because I can't verify why the pressure control solenoid is being commanded 100%. The good thing is that the PCM did fix the harsh engagement. So a little bit of electrical problem, and yes, I still ended up putting a PCM in it. But I put a PCM in it with some faith. I had some confidence that I felt like it was going to do something because nothing was telling the PCM that I needed 100% pressure control. I didn't have a code for anything that was pressure control related. So, hope this helps somebody. And as always, please subscribe to my channel if you want to see some more of these type of videos. I am probably going to do some more like this if I get a positive response on them. If you don't like them, give me a thumbs down. These do take some time to put together, and so if nobody will like seeing them, I'll just not put them out. So, thanks again for watching.